Okay, good day. This is Honors Algebra 2. I am Mr. McCully, and this is the video presentation for Section 5.2 on dividing polynomials. Let's get right to it. Today, we have two learning goals. We're going to use long division to divide polynomials, and we are going to use synthetic division to divide polynomials. But before we get to that, let's go back to third grade when we all learned how to do division, and let's talk about the parts of a division. So let's say, as a for instance, I decided to go 4 divided into 13. Now that's not going to go evenly, and I know that, but let's go through how we would have done it back in third grade. I would go, does 4 go into 1? No, it doesn't. Does 4 go into 13? Yes, 4 goes into 13 3 times. 3 times 4 is 12, and now when I subtract, I'm left with 1. And because 1 is less than 4, I know that I am finished, and I would put a little remainder of 1. And we can see that if I were to put this back together, I could check by going 4 times 3 plus 1, and that would be equal to the original 13 that I have here. Now, just as, again, a little bit of a reminder, this value here is the divisor. This value right here is the dividend. This value here is called the quotient. And this value here is called the remainder. Now, I went through all of that so that we could discuss the division algorithm. And the division algorithm essentially says this: if f of x and d of x are polynomials such that the degree of d of x is less than or equal to the degree of f of x, then there exists unique polynomials q and r such that f of x is equal to d of x times q of x plus r of x. And if r of x is equal to 0, then d is said to divide f. So again, why did I go through all of that? Because when we're dividing polynomials, we are actually doing that division algorithm. Think of this right here as my d of x, the divisor. Think of my quotient here as the q of x, and my remainder as the r of x, and my dividend as f of x. And if we do that, we get d of x times q of x plus r of x equals f of x. And that is what we have right here in the division algorithm. So this division algorithm is nothing more than the long division that you learned in third grade. We are going to apply that to polynomial expressions, not just numerical values. The remainder theorem is an important portion of this because we want to know when polynomials actually divide each other. And there's an important relationship to that. Just as a quick review, let's go back to here and talk about what it means to divide. And so if I divide 4 into 13, I have a remainder. Therefore, I would say that 4 does not divide 13. But if I go 4 divided into 12, well, if I go 4 divided into 12, 4 goes into 12 3 times. So if I go a 12 there and I subtract, I get a 0. So while 4 does not divide 13, 4 does divide 12 because there's no remainder. If there is no remainder, or we get a remainder of 0, we get some very significant things in polynomial division. And they go like this. If a polynomial f of x is divided by some linear factor x minus k, the remainder r is r equal to f of k. And so what that means is that if I take that k and I plug it into the function, I get the remainder back out, which is a really neat result. From that, we have some conclusions. The remainder r gives the value of f at x equals to k. That is, r is equal to f of k. If r equals to 0, then we can say x minus k is a factor of f of x. And if r equals 0, then the point k0 must be an x-intercept of the graph of f. It is these facts that allow synthetic division to work for us in a moment. Let's talk about the difference between long division and synthetic division. Long division can be used for any type of division for two polynomials. It will give you the remainder. Synthetic division is what we will be using more often because we usually divide by linear factors. It is much faster, but it can only be used when the divisor is a linear factor. So if you have a divisor that has an x squared in it, synthetic division will not work. So we have to be careful. My first example is we're going to divide a polynomial by a monomial, and we want to simplify this. Before we can simplify this thing, let's review a property of fractions. When you add fractions, we always say this over and over and over. You have to have like denominators. So from that, if I say a plus b over c, then for me to have done this addition, I would have had to have two fractions to add, a over c plus b over c. These two fractions have like denominators, so I can add their numerators. Similarly over here, because I have this addition of three terms in the numerator, I have three fractions with the same denominator. So I can rewrite this as 6x to the third y to the fourth over 3x squared y minus 12x squared y over 3x squared y plus 9x to the fourth y to the third all over 3x squared y. Because I am subtracting a sum or a difference of a fraction, I have to have common denominators to do that subtraction. So here I'm just going to simplify each fraction. From the last lesson, all we're going to do is simplify each numerical value and each pair of variables. So 6 over 3 gives me 2. X to the third over x squared, I subtract 3 minus 2 will give me x to the first, but I won't write 1 as a power. 4 y to the fourth over y to the first, 4 minus 1 will give me y to the third. In my second fraction, I have my minus. 12 over 3 will give me 4. X squared over x squared gives me 1. Y over y also gives me 1. So 4 times 1 is just going to be 4. Finally, 9 over 3 gives me 3. X to the fourth over x squared. 4 minus 2 gives me x squared. Y to the third over y to the first. 3 minus 1 gives me 2, so I have y squared. And that is my final division. I'm going to go through this long division problem here, but before I start, I do want to point out right here that you'll notice I have a 0x squared. Now we would never write 0x squared in our final answer. And you would lose points if you did. But this is not a final answer. And for this division, wherever we have a missing place, we're going to put a placeholder in. And we'll do that for synthetic division as well. So it's important to have our placeholder. So for us to do this long division, we are going to look at this leading term and this leading term. And I'm going to ask myself, what times x is 3x to the fifth? Well, 3x to the fourth times x is 3x to the fifth. And you'll notice I write it not above the 3x to the fifth, but I keep everything in line for my columns. So 3x to the fourth times x will be 3x to the fifth. 3x to the fourth times 1 will be 3x to the fourth. This thing I am subtracting away. Now 3x to the fifth minus 3x to the fifth is 0, and that's what I want. But negative 4x to the fourth minus 3x to the fourth is going to be negative 7x to the fourth. I bring down my 2x to the third. And this time I ask, what times x is negative 7x to the fourth? Well, negative 7x to the third times x is negative 7x to the fourth. So I distribute negative 7x to the third times x. Negative 7x to the third times x is negative 7x to the fourth. Negative 7x to the third times 1 is negative 7x to the third. Again, I am subtracting. But in this case, when I subtract a negative, it's like adding a positive. So negative 7x to the fourth plus 7x to the fourth, those cancel out and I'm left with 0. 2x to the third plus 7x to the third gives me 9x to the third. I then bring down my 0x squared. I ask myself, what times x is 9x to the third? Well, 9x squared times x is 9x to the third. So 9x squared times x is 9x to the third. And then 9x squared times x is 9x squared. When I do this subtraction, these cancel and I'm left with negative 9x squared in that column. I bring down the x and I ask myself, what times x is negative 9x squared? Well, negative 9x is. And so I distribute negative 9x times x is negative 9x squared. Negative 9x times 1 is negative 9x. And again, I'm subtracting. When I do that, I get the first two terms to cancel out, and then positive x minus a negative plus a positive, x plus 9x is 10x, and I bring down this negative 1. Finally, what times x is 10x? Well, 10 times x is 10x, so 10 times x is 10x. 10 times 1 is 10, and when I subtract that away, the first two terms cancel, and I'm left with negative 11. And so for this one, here is my divisor, this is my quotient, this is my dividend, and my final answer is 3x to the fourth minus 7x to the third plus 9x squared minus 9x plus 10 plus, remember we had a remainder of negative 11. So here's what we're going to do. We're going to make this not positive here. We're just going to make this a negative 11 over the dividend, which is x plus 1. And that is my final answer. Let's talk about how to do synthetic division. Synthetic division only works when the divisor is linear. It uses synthetic substitution. Find the value that makes the divisor, the factor, equal to 0. The resulting values are the coefficients of the quotient of the remainder. So the steps from the book, if you go to your book on page 313, you'll see these steps, and they are as follows. 1, we are going to write the coefficients of the dividend so that the degrees of the terms are in descending order. Write the constant r of the divisor, x minus r, in the box and bring the first coefficient down. Multiply the first coefficient by r and write the product under the second coefficient. Add the product and the second coefficient. Repeat steps 2 and 3 until you reach the last column. The numbers along the bottom row are the coefficients of the quotient. The power of the first term is 1 less than the degree of the dividend. The final number is the remainder. Now, I know that's a lot of words, but it's actually fairly simple. So I have this synthetic division as my example. So the first thing I want to do is I want to write the coefficients of the dividend. So in a division that's written like this first value here is the dividend. So the coefficients, well, I have a 1, and you should note there is no x squared term. So we need a 0. I'll put a line for it through it so you don't think it's a O as a placeholder. So I have this 1 is for the x to the third. I have a 0 for the x squared. I have a -3, and then I have a 1. The next thing that we're going to do is we're going to draw a line, and we are going to, what value makes the divisor equal to 0? In this case, what makes x minus 1 equal to 0? What value for x makes this expression 0? X equals 1 makes the divisor 0. And so I am going to put a 1 here. Now, we bring down the first coefficient, 1. 1 times 1 is 1, plus this value is 1. 1 times 1 is 1. -3 plus 1 is -2. -2 times 1 is -2. -2 plus 1 is -1. So from that, these values are the coefficients of the quotient. And this is your remainder. All right, so since we started this dividend with x to the third, our quotient will start with a x value that is 1 degree less than the one above it. So we'll have a 2 there. So it will be 1x squared plus 1x minus 2. We'll finish with -1 over our divisor, which is x minus 1. And that is our synthetic division. Well, I know I only had one example for both of those, but my lesson is starting to drag on. So I encourage you to come to an office hour if you are still struggling with this. And I will work through a couple more examples with you if you come to an office hour. But that's all I got for today. So The Mandalorian fun fact of the day. The Mandalorian uses a technology called stagecraft, where virtual sets are projected around the actors and the backgrounds are filmed whole with the actors in the foreground. And so you don't have a lot of, no green screen and not a ton of digital effects. Well, that's all I got for today, folks. Have a great day. Goodbye.